Hello everyone, welcome back to our channel. So today we are there to solve another matrix problem which is there in blind 75 SD sheet as well. So the name of the problem is rotate matrix by 90 degree, right? And on LeetCode the problem name is rotate image. It is quite similar thing, okay? So let us read the problem statement first. So we have been given an n cross n 2D matrix which is representing an image. Okay. So we have to rotate the image by 90 degrees, right? So in the clockwise direction. Okay. And one more thing, we have to rotate the image in place. That means we have to modify the input 2D matrix directly. That means we can't use anything extra. Okay. So we do not, that similar thing is written over there. We can't allocate another 2D matrix and do the rotation. Okay. So in this example that is taken from the LeetCode itself, I will show you through this. This is the matrix. Okay. So after the rotation, this matrix becomes like this, right? Can you observe what happened? Basically this particular matrix get rotated by 90 degree. If you can carefully observe, what happened is basically this part got turned out with this, okay, because 741 got on the horizontal line. That means it is getting rotated by 90 degree. You can see the angle. This is like this. This is side like this, 90 degree. Okay. So the explanation part is here. Although we also know that in mathematics, what we do basically, like we used to solve matrix questions. Okay. So similar technique we will use here. I will tell you in the optimal approach. But first of all, I wanted to all you guys to have a look on the constraint. Like matrix length is basically n cross n, which is n should be greater than equal to 1 and less than equal to 20, and matrix ij, that is basically the cells, should be greater than equal to minus 1000 and less than equal to 1000. So the brute force approach for this is basically this thing, like we will make the copy of a new matrix, and we will copy the elements from the original matrix to the new matrix in a rotated manner. Then the element at ij in the original matrix move to j comma n minus 1 minus I. That means the rotated by doing this operation, the matrix will get rotated in the new matrix. Okay. And after that we need to copy the new matrix back to the original one. So for this we can do this, but the time complexity for this approach will be O of n square, since we traverse the entire matrix, and space complexity will also be O of n square because we are using extra matrix. Okay. Just for the building of the approach, we can think of this idea, but this idea is just an inefficient one. So we will try to think something better solution for this question. So what you guys think of whenever we talk about if matrix get rotated or matrix get turned? So basically we know the concept of transpose, right? Okay, where the rows becomes columns and columns becomes rows. Similar concept we will use over in this question. Okay, I will tell you how everything is going on. So basically idea is we rotate the matrix in 2 steps without using the extra space. That means we will not be using the extra matrix. Like earlier in brute force, what we were doing was basically copying the original matrix. Then what we will do, basically we will transpose the matrix. We will convert the rows into columns by swapping the matrix ij with the matrix ji, right? So what is happening over there, basically in this, what is happening is matrix ij with my matrix ji, the rows, matrix ij is basically row and matrix ji is basically column. But what we are doing is basically we are swapping rows and columns. So now after swapping, what will happen is basically the rows will become column and column will become rows. Okay. Similarly, like I wanted to show you all how thing works. Like here, this first row, that is 147, that is it will, after rotation it will become column, that is this. Okay. So That means rows becomes column and column becomes rows. So basically we will reverse each row, because you can see this is 147, but after becoming column that it will become reverse like 741. Okay, this is 258, but it will become reversed, that is 258 in reverse direction. So what we are doing it after doing the transpose of a matrix. So basically after doing the transpose of it, we have to reverse the rows, right? So reverse similar thing written over there basically. So we have to swap the elements in each row to get a 90-degree clockwise rotation. Okay, so then what we can basically, this was the simple approach for this. And let's see the LeetCode interface for the code part. So what I am doing, what I have done is basically this is the initialization, and there are basically two steps as I told you in the approach. That is step what we are doing basically we are doing the transpose concept, that is transpose the matrix. So basically transposing, by saying transposing, what we mean is basically we are swapping the matrix. That means the rows and columns we are swapping it out. Okay, so for doing so basically we use two for loops. One is nested over there. So basically first for loop basically will iterate from 0 to n, and it will increment, and after that there will be a nested for loop. So for this thing is for basically j starts from i+1 to avoid redundant swaps, right? After that we are using the swap function over there. LeetCode allows you to use inbuilt swap function, but otherwise you have to declare it basically above this rotate function you have to declare swap also. Okay, so basically after doing this we have another step, that is reversing each row to achieve 90-degree rotation. Similar thing is there, very easy. Basically after doing the for loop we are calling the reverse function, that is matrix I dot begin and matrix I dot end, basically reversing each row in place. Now you all will think like how reverse function is how we have called directly, but LeetCode allows you to use functions like reverse, swap directly without declaring it. But if you are doing on a compiler or somewhere like that, you have to basically you have to first of all you have to make the swap function and reverse function, then only you can use it over here. Okay, so basically this was the code. And if I talk about the time complexity for this code is basically it will be time complexity will remain same O of n square, basically because we are doing the both transposing and reversing takes O of n square only. So after that what we are able to reduce is basically the space complexity, that is O of 1, because we haven't used any extra matrix to store the store the values, right? We have just modified the original matrix, so the no extra space will be used, so space complexity will be O of 1. I hope I was able to explain you this question well. If you guys understood the solution, please hit the like button and also share it with the other students as well. Thank you.